Hello, this is a video for Artificial Intelligence, Kennesaw State University Spring 2017. What you're seeing now is the GUI for the SARSA Lambda machine learning project. SARSA Lambda is SARSA learning with eligibility tracing. This means a Q table is used as a knowledge base for the agent, and a trace, or E table, is used to update this knowledge base. The light blue square represents the current position of the agent, the green is the current path of the agent for this iteration, and the gold is the goal of the agent. The black squares are walls, or cells the agent should not walk into. The arrows represent the best action to take in a given square as per the knowledge base. It is possible for the agent to walk off the grid world and into a wall, and over time should later learn to avoid this from happening. The colors represent the dominant value from a cell and vary from a pinkish red to a dark blue to show a contrast of learned values. Dark blue shows when a value is closer to 0, and pinkish red if the value is close to or above 1. Thus, the pinkish values show where more useful learning has occurred. I initialized the Q table to contain all zeros. I did this so that the agent would start with a clean slate. My intention was to then have the agent only learn useful information. The Q table contains values for north, south, east, and west. Each directional value represents the potential value obtained from the next state when taking that action. The key difference between SARSA learning and Q learning is that in SARSA learning, a state in the Q table is only updated after leaving that state. The current trace, shown in green, represents the current values in the E table. The trace contains its highest value closest to the agent and trails off the farther back in the current path. This is to update the Q table more strongly and more quickly with values that are more recently affected the agent. At the beginning of training, the agent should mostly explore and over time slowly start to exploit more of its knowledge to get into the gold more quickly. To accomplish this, each time the agent makes its way to the gold, the likelihood to perform a random move decreases. This is called the epsilon decay. In this training session, to adjust the speed of learning, I used a learning rate of 40%. I also used a discount factor of 0.8. The discount factor is used when updating the Q table. A value closer to 1 will make the agent consider more of the future rewards, and a value closer to 0 makes the agent consider more of the present.